Hi, my name is WeitaoSun. Me and my team with LiyingHan will introduce our final project, Intelligent Auto Feeder with IoT. Pets, especially cats, are raised in more and more families. An auto feeder becomes a good choice to take care of pets when people are away from home. There are lots of auto cat feeder machines on the market, but we find them to have a similar problem, that those machines can only feed cats with fixed amount and fixed period, and this may cause food waste. We want to design an auto feeder with goals that it can feed cats automatically and smartly, have server and silent ends, and allow user to control and monitor it. To achieve those goals, we need to complete three major tasks. First, we need to detect remaining food and water. And second, we should be able to add food and water dynamically according to the remaining amount. Third, we should also allow manual feed and the user can receive feedback or see current status of machine on a mobile app. Here is the overall diagram of our project design. There are three main parts. First part is local machine part. It is used to collect machine data and do feed actions. Second part is cloud server part. It's used to build connection between users and auto feeder. And it can store user general setting like feed frequency, feed amount in cloud. And third part is user app. It can enable user to monitor the auto feeder status or logs. Also, user can control auto feeder manually. This is the sequence diagram of nanos. Since the feed action needs to keep sending pulse to motors, and that will cause the whole program to be blocked. Thus, we use an additional nano as a driver to drive motors, and the master nano only need to send a command to driver. Then the driver will do the feeding job. Thus, in this way, we avoid blocking the program with running on master nano. The communication is built by Bluetooth LE. On Nano, we use a Arduino BLE library, and on Raspberry Pi, we use a BluePy library. Nano works as peripheral, and Raspberry Pi works as central. On Master Nano said it has an infinity value to send auto-feed data to the server, like the remaining food amount. And also it will grab control command from server to the control command, meaning how many quarter lap the motor need to rotate. As long as this value is greater than 0, a master nano will send this command to driver nano to do the feed operation. There is another thing we need to point out. There are actual two hardware implementations of serial on this nano. One is serial, which is used to communicate with a PC via USB port. Another one is serial 1, which is used to communicate with another device via TX-RX port. Thus, if we want to connect these two nanos, we need to use serial 1 instead of serial. On Raspberry Pi, we use the BluePy library to build Bluetooth with Nano and use the request library to handle HTTP requests such as GET, POST. It uses long polling to update the command from server per second by GET method. Also, it uses POST method to send Nano's data to server so that the server can make decisions based on those data. And the paired feeding feature also implemented on Raspberry Pi. Raspberry Pi will keep tracking the time interval between current time and last feed time. If the interval is equal or greater than the user setting value, then Raspberry Pi will automatically change the command value, which is CMD, so that it can let auto feeder convey food. On the server side, we use the Flask framework to build a HTTP server, which listens at port number 5000. It provides several GET and POST methods to allow Raspberry Pi or user's application to get data from the server or set data to the server. The following are the features of each HTTP request handler function. The first is feed. This allow user application can use the API to manually send a feed command to auto feeder to let it convey food. In our design, while the user sending the feed command, it also need to send a password in the JSON format to do the identification. and the server will check the remaining food amount in the bowl. If the remaining amount is too close to the target amount, the server will inhibit this manual feed option and return an error message to the server to see how much food is in the bowl. Otherwise, this function will set the CMD value to the corresponding quarters that the motor needs to rotate. And these two get set pairs used to enable user set auto phase frequency and amount. And the get log function is provided to the user to let the user can get the recent 10 activities, and get CMD function is provided to the Raspberry Pi to enable it to get the CMD from the server. The CMD is an integer and it means how many quarters the machine needs to rotate. Because our machine will deliver food 4 times in one lap, thus the minimal countable unit is a quarter lap. And by our test, in 1 quarter lap, it will deliver around 5 grams of food. Thus, CMD is calculated by the amount divided by 5 grams. For example, if we want to feed 20 grams of food, then the CMD value should be 4. And the get data is this API is provided to Raspberry Pi to enable it to send local data to the server in JSON format. And the reset is an API that lets Raspberry Pi to let the Raspberry Pi tell the server the last feed command has been received and processed.
The client end is a mobile app. We developed an iOS app using Swift and Swift UI. Users can click this blue button to feed manually. Then the app will send an HTTP post request to the server, and the server will control the feeder to add food to containers. The setting functions here allows users to set the auto-feeding frequency and amount. The activity history function allows users to view previous activities and the status of the feeder. Our auto feeder should have the feature to detect the water remaining in the container. However, since we didn't manage our time well to complete the 3D printing of the water tank, and our camera also has some issues, so we just realized the basic function of water level detection using OpenCV. If we are given an image of bottle, we can calculate the percentage of water left in it. We first perform image binarization and smoothing and detect all contours. Then we will find the largest contour and bound it by box. We can calculate the remaining amount of water by reading the height of the box. Here we can show you a demo.
So this is the setup of our project. There are 2 nanos. First is master nano used to communicate with Raspberry Pi via Bluetooth, and it can send some control message to the driver nano by the serial port. And the driver nano is used to drive the motor inside the feeder. And the Raspberry Pi will communicate with the server via internet. And you can see here is the data sent from the master nano, and the Raspberry Pi will send that data to the server, and then we will show how to control user apps.
And so this is the app for our cat feeder. And first we can click the settings to set the frequency of auto feeding. This is where to set the feed interval, and the default value is 12. It means we can feed once every 12 hours. And we can also change this to like 6 hours for each feed. And also we can change the amount in each feed, 20. So then after we click this set, we can see on the server, the log also shows this. So our auto feeder should be able to feed the cat every 6 hours, and also for each feeding, it should feed 20 grams. And we can also manually feed the cat by clicking this blue button feed. So after we click this, we can see the cat feeder is working now. And also we have a function activity history. So here we can see the recording of previous activities. So like this is the setting frequency where we set our auto feed frequency, and this is where we manually feed the cat. Our auto feeder can decide the amount to feed dynamically based on the remaining amount in the food container. So here, this 10 grams, it is the weight of the food in the container. If we click feed the first time, it succeeds. And now the weight becomes 40. And if we click feed the second time, it fell. And this is because the food in the container is already enough.
So this is the setup of our.
We perform tests to evaluate our auto feeder, and the results show that the feeder can deliver food automatically. Users can monitor the log and manually feed pets. The feeder can also dynamically adjust the feeding amount based on the remaining food and monitor the amount of remaining water by CV, given an image of a transparent water container. Our machine achieves essentially all of the designing goals, but there are some issues need to be solved. First, our power supply will overheat if the motors work for a long time continuously. If overheat happens, the power supply cannot support enough power to drive the motors until it cools down. And second, some components of our machine are either too complex or expensive. For example, we use 2 Arduino Nano and a Raspberry Pi in total. And the third issue is that the water detection part is incomplete and the current algorithm only works in very ideal cases. And in the future, we plan to use better motor and machine design. And to reduce components and costs, we plan to use PCBs to substitute wire connections. We can also replace Nano and Raspberry Pi by a single ESP8266 Arduino to build connection with the cloud server. We can also add more features to the mobile app, like supporting the user logins. And we can further finish the 3D printing of water tank and add a camera to take pictures. We can also improve the OpenCV program by using a better model and maybe combining machine learning and computer vision. And in summary, although some functionalities require special conditions to work, we have solutions to solve those problems in the future. And our machine fulfills our design to avoid overfeeding problem. Thank you so much.